Mars. The fourth planet from the Sun, often referred to as the Red Planet due to its reddish appearance, has long been a source of fascination and wonder. The very name conjures images of a distant world, a place that seems both familiar and alien at the same time. Its rusty hue, visible even from Earth, hints at the iron oxide that covers its surface. A celestial tapestry woven with threads of rust and gold, Mars presents a landscape that is both stark and beautiful. Its surface is dotted with ancient volcanoes, vast canyons, and dry riverbeds, painting a picture of a planet that was once geologically active. Since antiquity, this crimson wanderer has captivated our imaginations. Ancient civilizations named it after their gods of war, seeing in its blood-red color a symbol of conflict and power, a beacon in the night sky, whispering tales of alien landscapes and the possibility of life beyond our own. The idea that Mars could harbor life has been a tantalizing thought for centuries, inspiring countless works of fiction and scientific inquiry. For centuries, Mars remained a distant enigma, its secrets veiled by the vast cosmic gulf that separates us. Early astronomers could only speculate about its surface and atmosphere, their telescopes revealing little more than a reddish disk. But humanity, a species driven by curiosity and a thirst for exploration, yearned to unlock its mysteries. The advent of space exploration in the 20th century marked a turning point in our quest to understand Mars. The allure of Mars lies not just in its beauty, but in its potential. It is a world that, despite its harsh conditions, holds the promise of discovery. The possibility that Mars once had liquid water and perhaps even life makes it a prime target for exploration. It is a world tantalizingly similar to our own, yet strikingly different. Mars has seasons, polar ice caps, and weather patterns, but its thin atmosphere and lack of liquid water on the surface make it a challenging environment for life as we know it. Could life, in some form, have once existed on this now arid planet? The discovery of ancient riverbeds and minerals that form in the presence of water suggests that Mars was once a much wetter world. Could it still persist, hidden beneath its surface, awaiting discovery? The search for microbial life continues, with scientists focusing on underground caves and the possibility of subsurface water. These questions have fueled countless missions to Mars. From the early flybys and orbiters to the sophisticated rovers and landers of today, each mission has brought us closer to understanding this enigmatic world. Each one bringing us closer to understanding this enigmatic world and our place within the cosmos. As we continue to explore Mars, we not only learn about the planet itself, but also about the potential for life beyond Earth and the future of human exploration in the solar system. The dream of one day setting foot on Mars is no longer confined to the realm of science fiction. With advancements in technology and international collaboration, the goal of human missions to Mars is becoming increasingly attainable. Imagine a future where humans live and work on Mars, conducting experiments, growing food, and perhaps even finding evidence of past or present life. This vision drives the efforts of space agencies and private companies alike, pushing the boundaries of what is possible. The Red Planet beckons to us, not just as a destination for exploration, but as a symbol of our enduring quest for knowledge and our unyielding spirit of adventure. It inspires the next generation of scientists, engineers, and dreamers to look up at the night sky and wonder what lies beyond. As we continue to send missions to Mars, each new discovery brings us one step closer to answering the age-old questions about our place in the universe. The journey to Mars is a testament to human ingenuity, perseverance, and the unending desire to explore the unknown. The Red Planet beckons, and humanity is ready to answer the call. With each mission, we unravel more of its mysteries, bringing us closer to a future where Mars is not just a distant world, but a new frontier for human exploration and discovery. Our journey to understand Mars began in earnest in the 1960s with the Mariner program. This ambitious series of missions marked humanity's first serious attempt to explore the Red Planet. The Mariner program was a bold step into the unknown, driven by a desire to expand our knowledge of the cosmos and our place within it. Mariner 4, a testament to human ingenuity, provided our first close-up glimpse of the Martian surface in 1965. This mission was groundbreaking, as it was the first time we had ever seen detailed images of another planet's surface. The spacecraft traveled over 325 million kilometers to reach Mars, capturing 21 images that forever changed our understanding of the planet. The images, grainy and black and white, revealed a desolate, cratered world, seemingly devoid of life. These haunting pictures showed a barren landscape, pockmarked with craters, and no signs of the canals or vegetation that some had speculated about. It was a sobering moment, but also an exciting one, as it opened up new questions and avenues for exploration. Yet, this was just the beginning. The Mariner missions laid the groundwork for future exploration, proving that we could reach Mars and send back valuable data. Each subsequent mission built on the successes and lessons of its predecessors, pushing the boundaries of what we knew and what we could achieve. Subsequent missions like the Viking landers in the 1970s painted a more complex picture. The Viking program was the first to successfully land on Mars and conduct experiments directly on its surface. These landers were equipped with sophisticated instruments designed to search for signs of life and study the planet's geology and atmosphere. They found evidence of ancient riverbeds, hinting at a time when liquid water flowed freely on the Martian surface. This discovery was monumental, suggesting that Mars may have once had conditions suitable for life. The presence of these riverbeds indicated that Mars had a more dynamic and potentially habitable past than previously thought. The quest to unravel the history of water on Mars and its implications for life became a central theme in our exploration. Scientists began to focus on understanding the planet's climate history and the role water played in shaping its surface. This research has profound implications, not just for our understanding of Mars, but for the search for life beyond Earth. As we continue to explore Mars, each mission brings us closer to answering the age-old question, are we alone in the universe? Billions of years ago, Mars may have been a very different place than the cold, dry desert we see today. Imagine a planet with vast oceans, flowing rivers, and a thick atmosphere that could have supported a climate much warmer and wetter than the Mars we know now. This ancient Mars might have been a cradle for life, a place where the conditions were just right for life to begin. Evidence suggests that Mars once possessed a much thicker atmosphere, one that could have supported liquid water on its surface. This thicker atmosphere would have provided the necessary pressure to keep water in its liquid state, allowing it to pool into lakes, rivers, and perhaps even oceans. The presence of liquid water is a tantalizing clue because on Earth, water is essential for all known forms of life. This ancient Mars, warmer and wetter, may have been conducive to the emergence of life. Scientists believe that where there is water, there is the potential for life. The rivers and lakes of ancient Mars could have provided the perfect environment for microbial life to develop. These water bodies would have been rich in minerals and nutrients, creating a fertile ground for life to take hold. The presence of liquid water is considered a key ingredient for life as we know it. Water is a solvent that facilitates chemical reactions, and it is within these reactions that life can begin. On Earth, water is the medium in which the building blocks of life, such as amino acids and proteins, can form and interact. If Mars had liquid water, it could have had the same potential for life. On Earth, life teems wherever water is found, from the depths of the oceans to the driest deserts. In the deep ocean, hydrothermal vents support entire ecosystems, while in the arid deserts, tiny microbes thrive in the most extreme conditions. This resilience of life on Earth gives scientists hope that life could have existed on Mars as well, even if only in microbial form. If Mars once had abundant liquid water, it's plausible that life, even in microbial form, could have arisen there as well. The search for evidence of past life on Mars continues with missions like the Mars rovers exploring the planet's surface for signs of ancient water and the chemical signatures of life. Each discovery brings us closer to understanding whether Mars was once a cradle for life, and what that might mean for the possibility of life elsewhere in the universe. Today, the Perseverance rover, a marvel of modern engineering, roams the Martian surface, seeking answers to these fundamental questions. Perseverance landed in Jezero Crater, a site chosen for its potential to harbor signs of ancient life. Billions of years ago, Jezero Crater was a lake, fed by a flowing river. The rover is equipped with a suite of sophisticated instruments designed to study the Martian geology, climate, and search for biosignatures, telltale signs of past or present life. Perseverance is also collecting rock and soil samples, carefully storing them for a future mission that will return them to Earth for detailed analysis. One of Perseverance's most intriguing discoveries is a rock nicknamed Chayava Falls. This rock, found in Jezero Crater, contains intriguing organic molecules. These molecules are not definitive proof of life, as they can be created through abiotic processes as well. However, their presence in a former lakebed is significant. It suggests that the building blocks of life may have been present on ancient Mars. Further analysis of these molecules, both by Perseverance and in laboratories on Earth, could provide crucial insights into the possibility of past Martian life. While Perseverance can perform sophisticated analysis on Mars, the most definitive answers about past Martian life may lie in returning samples to Earth. Laboratories on Earth possess a vast array of analytical techniques that are simply not feasible to send to another planet. Analyzing Martian samples in terrestrial labs would allow scientists to scrutinize them in unprecedented detail, potentially revealing the presence of fossilized microbes or other definitive biosignatures. The effort to return Martian samples to Earth is a testament to the importance of this endeavor. While much of the search for life on Mars focuses on ancient environments, some scientists believe that life could persist on present-day Mars, albeit in hidden havens beneath the surface. One such region of interest is Acidalia Planitia, a vast plain located in the northern lowlands of Mars. Acidalia Planitia is thought to contain vast deposits of water ice beneath its surface. If geothermal activity exists in this region, it could melt some of this ice, creating subsurface aquifers where life could potentially exist, shielded from the harsh radiation and frigid temperatures of the Martian surface.